Good morning.
Morning. Good morning, everyone. Today, pretty much discussion is what we are going to do. So the practice test or the review questions or questions from any homework anywhere you can ask today.
Start right now.
1 second. Still people are coming in. All right, I'm going to take attendance now. Okay, now I'm going to share the screen. Okay. I have the review questions on the screen. I also have the latest homework assignment. So you can ask question from last homework, the one you turned in today, or from review.
Can you see 1F on the review sheet? The exam, 1F.
Did you say 1F?
Yes, 1F on the, yes.
Review, on the review, okay. All right, 1F says, determine the values of the following logical expressions. Now, by the way, remember, logical expressions will produce true or false as value. Only if you convert them to integer, you will get 1 or 0. In one of the assignments in which you were supposed to evaluate the logical expressions and write solutions, write the results, the value of the expression, some of you presented 1 and 0. So I accepted that because the book kind of said, write true or false or 1 or 0. But that was just for that question, it was accepted. But always the logical value is true or false. And only if you convert it to integer, it'll be 1 or 0. So
yeah, the answers in the back of the exam review give it as 1 and 0.
That's yeah, I realized that was my mistake. So
Okay.
you should write true or false, not 1 or 0. It's yeah, things like that I have missed in places, and I need to fix those. So just remember from here on, logical expression will produce true or false, not 1 or 0. But if you convert it to integer, it'll be 1 or 0. All right, so I'm doing 1F, which says z less than 0. Z is negative, -2, so z less than 0 is true. So I'm writing on the board, the first expression is true. And then we have or. Now, x not equal to y minus z. Y minus z is 5, and x not equal to y minus z is false. So that's false. And then we have and operator. X less than 0 is false. Okay, so the question is, which operation will be next? There's an or, there's an and. The and operation will be next, because in the order of precedence, and will be done before or. So they're both false for the and, so the result is false. Now we have, the next one is or, so we have a true on the left side of that and false on the right side. So the answer is true. That's your answer. Okay.
Okay.
Yep.
Excuse me, sir. Why is true again? If it's and our end is false, why is true?
Because the or operator, we have or operator. For the or operator, when you're operating or operator, only one of the two sides have to be true to get true. Okay, because that's what it means.
Okay.
Only if you have and operation, then both have to be true to get true.
Hello, Professor. We're not going over any other homework for
No, we can go
this.
over any question, anything today.
Okay, so for let me exit full screen. So can we go over homework number 12? Question
12, okay.
from section 4.1, number 4. Wait, no, actually number 6. Number 6.
Okay, it's still homework number 12, right?
Yes.
Okay. All right, I have the homework number 12 open. You said number 6, right?
Yes.
All right. Write a program to determine 4 raised to what largest power is under 2000. All right, I'm doing homework 12, number 6. So 4 raised to what power, what largest power is under 2000. So we need to determine the power. So we need to keep track of the power while generating all the powers. So I'm going to look at 4 to the 1 first, and then 4 to the 2. I have to keep generating these. The easiest way to generate those is to start at 4 in a variable. So I'm going to use variable n, int n equal to 4. And I need to keep track of the power. So it's best to keep track of the power this way. The power right now for the 4 is 1. It's 4 to the 1 we're dealing with. So therefore, power is equal to 1. If you, I noticed in some of your homework assignments, some of you started out with 0 or some other number so that your answer will come out right. That kind of thinking is always leads to, mix up and errors and things like that. If you think in a straightforward way like I'm doing, it'll be a lot easier. Right now, the 4 is 4 to the power 1, so therefore power is 1. And then if you need to make any adjustment to the power at the end, do that at the end, not at the beginning. It will complicate matters. Okay, so now I'm going to say while the number, our power, I need to find the number 4 to the power something that will be over 2000. It says under 2000, we'll take care of that, but we have to go over 2000. And our statement the loop has to be while n. So the n is where I'm going to put all those different powers. N is going to be, n is right now 4, but it'll be later 4 to the 2, 4 to the 3, 4 to the 4. All those will be generated as long as it's under 2000. So while n is under 2000, keep doing this. So even though the problem is asking about under 2000, we cannot change this inequality to the opposite y. And if I say n greater than 2000, then this condition will be false to begin with, and the loop will never start. So we still have to go with the same loop. While n is under 2000, I'm going to multiply. I need more than one statement inside, so I'm going to have the bracket. And then I'm going to multiply n by another 4 and put it back in n. That way n will be equal to 4 squared. And whenever I change the power of n, I need to change pow. So pow will increase by 1 to keep track of the power. So right now, n started at 4, and n under 2000 is true. So therefore, this will be executed, and that will change the n to 4 squared. So n was 4 initially. Now it's a 4 squared. And the pow was 1, and now it is 2. So both happened here. And after that, I go back to the top, and then under 2000 is still true. So multiply by another 4. So now I have 4 cubed, and the pow increases to 3. And it will keep going. And then it will, we can actually work this out. We don't have to work it out. So anyway, it'll keep going. And then at some point, n is going to be over 2000. Pow has the power that 4 was raised to get that number over 2000. So when it goes over 2000, the loop ends. And when the loop ends, our number is over 2000. So 4 to the 4, 4 to the 5. Let's say 4 to the 6 is the one that is over 2000. Then I don't want that number, because according to the problem, we need the number that is under 2000 and closest to 2000. So if this is over 2000, the previous one must be the one under 2000 and closest to 2000. So all I have to do is, when this loop ends, instead of printing pow, I need to print pow minus 1 less, because I know that that's what I need, the previous one. And some of you wrote the program and with the pow starting at 0, so that the final pow number will be correct. But if you do that, a reader will be finding it hard to understand, and you yourself can get lost with your approach if you manipulate that way. So use a straightforward approach, and like the n is 4, so power is right now 1, because it's 4 to the 1. And then n becomes 4 squared here, and power becomes 2. And if you do that, it'll be a lot easier to follow that. Okay, anything else?
Thank you. I also have a quick question. Yeah. It's like we always do homework and everything, and like you grade it by just like saying right or wrong. Is it possible you can like have solutions for the homework so that we can like refer back to them? Because like I have a whole bunch of questions, and like I don't want to take up all the time, because I want people to be able to ask their own questions.
Okay, yeah, I have no problem posting solutions, but what I found in the past is the students don't learn from solutions. It just doesn't work. So if I explain how to write, it works a lot better. So just by reading, they don't really understand it, and then it leads to all kinds of problems, frustration, and things like that. I'm here. I have office hours, twice a week, and I'm also having at the end of classes. Also, I'm willing to take questions. So you should ask me to explain. I'm willing to explain anything. So today is, pretty much dedicated to discussion. And so you can ask any question on any homework and I'll go over it.
Okay, so then can you go over 8 then from homework number 12?
No, if somebody else has, if somebody else has a question, they had to come forward and ask the question. So nobody else is.
I'm confused. I'm just confused because like when you comment on the homework, you just write right or wrong, and you don't really.
Whenever it's easy enough to tell you what is wrong, I do tell you what is wrong. But I can't write a paragraph of explaining what's wrong, right? Not on.
No, I'm not asking that.
You see, for you, it's one assignment. For me, 60 of them. Okay, 60 copies of them.
No, yeah, I understand. That's why I asked if
So
you could make
it's hard for me to write a lot of explanation.
I know that's why I asked if you could make that, and then you said no, and then you just told me to ask you, and I just asked you, and then you said no.
And always in the following class, I devote several minutes.
Okay, we can move on. It's okay.
Right. So you should always bring up the questions from assignment, and I can go over them. Yeah. Right now you want the 8, right? Number 8. Did you say?
If not, you can do 2C on.
Else.
I think this young lady asked me to go over number 8, but
okay.
She's not talking.
I said you can go to someone else.
Someone else, all right.
Maybe 2C on the review sheet.
2C on the review. 2C.
Like he just asked the question before me. I don't get what's the difference if I ask another question.
I'm saying you can ask your question. I'll go over it.
But you just said someone else has to go.
No. If someone, as long as nobody else is asking question, I'll go over your question. That's what I meant to say.
Okay, so then go 8 after him, please.
All right. Yeah, I'll do 8 after this. Okay, I lost what it was. Did you say 2C?
Yes, 2C on the review sheet.
All right, I'm looking at it right now. Int x equal to 5, y equal to 3, and then z is another int variable. X equal to y is false, and y less than 0 is false. So therefore, entire expression is false, and the false is converted to int and stored in z will be 0. Okay, are you with me so far?
How z is true?
It's not true. It's this is false. X equal to y is false. Y less than 0 is false, right? So this whole thing is false.
Oh, because on the answer you have C6. So I think it's saying that.
Look at the answer yet. I'm looking at this expression. This expression is
okay,
and therefore z will have a 0. Do you agree with that?
Okay. Yes.
So then this if statement says if z is 1, do this, but z is not 1. So therefore it's going to do this. Agreed?
Yes.
So x equal to x minus y. So x changes to 2 now. X is 2 now. And then z equal to, so x equal to 2. And then z equal to 3 times x. So z equal to 3 times 2, which is 6. Okay. So 6 will be printed on the screen. Okay, now I'm going to the other question. Number 8 from the homework 12. Clear the screen. Employees of a company are paid 300 base pay plus $18 per hour for each hour. Tax is taken from the salary at 9% rate. And we need to prepare a table that shows numbers 0 through 50 as the hours at the increment of 1, and then salary after tax in a second column. Okay, so let me begin with the main and declare my variables as float. I don't have to, the 300 and the $18, these are all constants for this problem. Only variable I need is salary. Salary will be changing as the hours change. And I'm going to make hours integer, but float salary. I'll call it sal. And then hours tax. I need tax. I don't see any other need for a variable. So int hours. And then I will write the title. Okay, so that would write the title. Now the hours number has to go from 0 to 50 at the increment of 1. So for loop is convenient. I'm going to write for loop. I don't know whether this is 4.1, so you didn't learn for loop at the time. So I'll use while loop. It doesn't really matter. So hours will begin at 0, so I can set it to 0 here. And while hours less than or equal to 50, hours will go up to 50. And for each hours, I need to calculate the salary. So sal equal to 300 base pay is 300. And then for the number of hours, there will be $18 per hour. So hours should be multiplied by 18. And this is your pay. 300 plus hours times 18. So some of you try to calculate the tax and add the tax right here in the same expression, which is a bad idea. You can easily make a mistake if you do that. Take another step for the tax. So tax equal to sal times 0.09. 9%. Okay. So after that, I have to take the tax away from salary. So sal equal to sal minus tax. So if you take 3 steps like that, then you won't make a mistake in the math. So now my salary is ready. So I'm going to see out both hours. After the hours, I need to tab over \t and then write the salary and then ENDL. And only after that, my hours will change. See, currently initially I started with hours 0. The problem says you need to work out the salary for 0 hours also. So even if the person has 0 hours, there will be a salary. There will be $300. So you need to calculate the tax and all that on that number, write it out. And I did. Now I'm ready to change the hours to the next. Only at the end of the loop, before going back to the top of the loop, you change the control variable of the loop. Hours plus plus and close right there. So with the new hours, you're going right back to the top. As long as hours is less than 50, you're working out the salary after tax and writing it out and so on. So that's all we need. When that loop finishes, our table will be ready. So just close the program here.
Could you do 2D and 17 from the review?
From the review, 2D
Yeah.
and 17.
Yeah, thank you.
2D is right here, char val equal to C, n equal to 69. And then if val greater than n is 69, val is C. So AB, lowercase c. So lowercase c is definitely greater than 69. So that is true. See, lowercase a is 97, right? So lowercase c will be 99. So therefore, that condition is true, and val equal to 90 is val is C, so val equal to 90 is false. Because val is 99. N less than 65 is false. So these two are false, and the next operation is the AND operation here. And both sides of that AND operation are false, so the whole thing is, so this expression right here is false. And the val greater than N is true, so therefore the whole thing is true. All right, so the entire expression is true. Agreed?
Yes, I just wanted to ask, will we be getting an ASCII table for the exam?
Yeah, yes, like last time, it was right at the top of the exam.
Yep.
Yeah.
Okay, thank you.
In the same way. So the whole thing is true, and therefore it will do this part, val equal to val plus 3, and see out val. So val is C. Now remember, val is a char type variable. So when you're doing val equal to val plus 3, I'm doing it on the board. Val equal to val plus 3. Let me explain the whole process. Val is a char type value, and since 3 is integer, it will convert both of them to integer. So therefore, the val will be now 99, and then 3 will be added to it. So now the 3 will be added, and now it becomes 101, 102, that is. So 102, and now you're assigning that to val. Now it's going to be converted back to character because val is character. So basically, when you add 3 to a character, you're going to get a character that is 3 places over to the right in the list of alphabets. So this will be now what? D, E, F. So it'll be F. That's what you're going to write. The output is F. What's the other one?
17.
17. Okay, you write a program that reads a floating point value for X from the keyboard and computes the sum of the series. All right, let's clear the board. The value of X has to come from the user. I'll declare the variable X as float. And then I also need a variable for the sum, initially 0. You need to have a value stored there initially. And the variable, yeah, that's all I see. And then in type variable, I may not need that, but let's declare that. Okay, so now ask to use it for the X. Enter value of X, C in X. So X is ready now. So this loop basically goes, the denominator has a number added to X, and that number is 0 in the first term, 1 in the second term, all the way to 50. So I can use the for loop controlled by that number, the number added to X, which is what N is going to be.
Sir?
Yeah.
The first term can't be divided by 0 because you'll get a fault.
Oh, no, I mean the number added to X.
Oh, got it.
Yeah.
Thank you.
So for N going from 0, the N is the number added to X in the denominator. N going from 0 to N less than or equal to 50, it goes up to 50 and increments by 1. For each one of those N, I need to calculate 1 over x plus n and add it to sum and put it back in sum. To accumulate sum of many things, you have to have sum equal to sum plus. I explained already why that's necessary, and still some students don't seem to have that. So sum equal to sum plus 1 over x plus n, and that's all I need. So even though the series looks complicated, this loop will do it. N going from 0 to 50, incrementing by 1. 1 over x plus n is added to sum. So when n is 0, 1 over x is added to sum and stored in sum. Then to the same sum, I'm adding, in the next time through the loop, to the same sum, I'm adding 1 over x plus 1 and putting back in sum. So already I have added these. And next time through the loop, n is 2 and 1 over x plus 2 is added to sum. So 1 over x plus 2. And it'll keep going all the way to 50.
You have to put a decimal after 1.
1 second, 831. After the numerator, no, I don't really have to because my x is float, so the denominator is float. So I don't need 1 point. Only numerator or denominator needs to be float for the entire expression to work out right.
Professor, is there going to be fill in the blanks like last time?
No, because this in the last test there were a lot of theory questions, right? Like what is computer and what does operating system do and things like that. So the blank, filling in the blank was necessary for that kind of question. But now we are into serious computer programming, and there's no such theoretical questions.
Okay. Is it possible we can go over 9 on the review?
Okay.
We can do that one already. Thank you.
Okay, I'm going over number 9. It says, assume the following simple tax table. I think I should start with the clear screen. So let's start. Tax table, the only permitted deductions are 3,000 per person in the family. Total amount paid as interest on the home mortgage. All right, taxable income, if it is more than 20,000, then 5% of the taxable income. So that's tax table. Okay, now the question is, write a program that repeatedly obtains the gross income number of membership in the family and the total mortgage interest paid from the user and computes and prints the tax amount for the individual. Okay, so the repeatedly obtains part belongs to the second part of the 4.5. Now this, remember, we decided not to have that in this test. So if I'm asking a question like this, I will ask that by asking to get the number 1 time, not repeatedly, only 1 time. So obtain the gross income and number of members in the family, and then calculate and print the tax. That's what we need to do. Okay, so gross income, float, gross, and net. We need net income later, and then tax. These have to be float. And in type variables, number of members in the family, members. Ask the user for income. and number in the family, number of members in the family, but I'll simplify that. C in grass and also members. After that, you need to deduct the 3,000 per person to get the net income. And then net income means the taxable income. And the interest paid on the mortgage. It doesn't ask you to, yeah, mortgage interest. I have to ask for that too, all right? So, interest. So I'm getting interest also from the user, which means mortgage interest. All right, once I get that, I need to calculate the net income or taxable income. I called it net, or you can call it taxable, whatever name is, net equal to gross minus number of members. Each member gets 3,000 deduction, so minus members, number of members, that's what that is, times 3,000 will be deducted, and also deduct the interest. So that gives you the net income. Now I had to follow the tax table to get the tax. Okay, so if that's going to be if else if structure. There is no other way to do this than if else if structure. There were 2 or 3 students writing all ifs, they thought they can handle it that way. What happens if I say if, let me begin with less than 20,000. You can begin with the 40,000 or over, or 20,000 or less. Either way, you can make it work. So if gross, net is less than 20,000, and the tax is 5%. So tax equal to 0.05 times net. Now I have to say else if, otherwise, students wrote this before, so let me explain why that's wrong. If net is greater than less than 30,000. So if it is some students wrote less than 30,000 and greater than 20,000, and net is greater than 20,000. So that means they're putting it in the bracket. So it appears to be right, but if you don't put it in if else if, there will be some numbers will not be in the will not be accounted for in your whole system. So if you do this way, for one thing, this comparison of net greater than 20,000 is being done second time, comparing net to 20,000. You don't, so you already compared it, net less than 20,000. So if that is not true, then it means it's over 2,000. So it's best to say else, and then that means net is over 2,000. After that, you only have one comparison. So why do you want to do the comparison over and over? That makes the program inefficient. So even if you make it work right with a bunch of ifs, it wouldn't be as efficient as it can be. So it is not recommended you write a bunch of if. For one thing, the too many comparisons you're adding, and also another thing is you cannot make it work perfectly. There will be some numbers that will not be accounted for. So it's best to write else. That means this is not true. If this is not true, then go here and check to see if net is under 30,000. So if this is true, then we are between 20,000 and 30,000, because already net less than 20,000 is not true. That's when it comes here. And that means it's over 20,000. And if this is true, then it's under 30,000. So it is in the bracket 20,000 to 30,000. And that's when tax is going to be 0.08 times net. Else, if net is less than 40,000, tax equal to 0.10 times net. And then just an else will take care of the other part, because net less than 40,000 is now not true. That's when it'll come here. It means it's 40,000 or over. So I don't need another if. Tax equal to 0.13 times net. So that's your tax, and computer prints the tax amount. So we just have to print the tax amount. There's no other condition on that. See out tax equal to tax. All right, anything else?
Can you cover 11B on the exam review?
11B. To replace the value of in-type memory cell num with the absolute value of the original value. Okay, let me clear the board. Now, absolute value means if the number is positive, you leave it the way it is. If it is negative, then you want to drop the negative sign and put the positive number back into it. So I'm doing 11B. Variable name is num. So all I had to do is look at the num and see if it is negative. If it is positive, you don't need to do anything. It's already absolute value. Only if it is negative, then num equal to, replace num with -1 times num. That'll make it positive. That's all you need to do.
Okay, thank you. I was thinking of something much more complicated, and that's pretty simple. Thank you.
They're all very simple. Whenever it says write a statement to achieve, it's usually very simple.
Number 14.
14. Okay. Now, those who have questions, you have to jump in. Otherwise, others will lose the time. 14. Write a program that obtains an integer from the user and counts how many odd numbers below that number, can divide it evenly, and prints the count on the screen. Okay, so we need to test all the odd numbers below that number, other than 1, and see how many of them divide. So we need the count. All right, so int num is the number. Num is where the numbers given by the user will be stored. And then we need to test our devices, and divisor is going to start at 2. Test for the divisor will start at 2. I'll use while loop. Test starts at 2. And I need a counter. So count equal to 0. Ask the user to enter the number. C in num. And then test numbers are going to go from 2 to 1 less than the given number according to the problem. Below that number, yeah. So let's make sure loop goes test number less than num. All the test numbers less than num should be tested. So while test number is less than num, I need to test to see if this test number is a divisor. So if test, wait, it says odd number other than 1, I just realized. So test number should begin at 3. We are not testing 2 because we only need to test all the odd numbers. So test number will start at 3. So if num modulus test, that's what I need to look at. Num modulus test equal to 0, then the test number is a divisor. And if it is a divisor, then my counter should increase. I'm not printing devices, I'm just counting them. Okay, so, and then test number should go up. And I can either, if I want to write test plus plus as the next statement, I can do that. Then I need brackets for the loop because there are 2 statements in the loop. Instead, I can just throw in plus plus right here behind the test. So test the current, oh, no, sorry. I keep forgetting that we are working with odd numbers. So I cannot do the plus plus there. I have to write a separate line. So curly bracket is necessary now. Test the current test number and then increment the test by adding 2 to it, because that's how you get all the odd numbers. I started at 3, and if I add 2, the next number is 5. Add another 2, it'll be 7. So you're generating all the odd numbers by adding 2. And that's all we need to do in the loop. When the loop finishes, the count is ready, so see out the count. All right.
Is it gonna be something similar like that in the test?
It could be. I'm not telling you what is on the test.
No, I know, but that was kind of like
yeah, something like that.
time.
Test. Why not?
Can I ask something?
Uh-huh.
Could you show, please, exercise 4B from today's homework, number 15?
Okay, today's homework.
4B, please.
4B.
These nuts are balls on your wall. We asked that Sausage and burgers, and this was the second time it was ordered. It was an amazing circuit breaker.
I'm sorry. Are you talking to me?
Yes, because seasoned waffle fries.
Food is good. God, this was good. Bro, all right, it's good.
Not expecting a burrito the size of a small child.
Sam.
Eaten a small child before.
Gentlemen, speak yourself.
All right, so let's clear the board. And I'm going over 4B in the homework assignment, the latest homework assignment. It says write a program to compute the sum 1 times 2 times 3, 1 times 2 times 3 plus 2 times 3 times 4, all the way to 39, 40, and 41. Okay, so let's, we need to keep track of these, the numbers. So my number is going to start at 1. And I can have one variable to track the terms. That'll be my n. So int n, and sum is going to be integer also. So sum equal to 0. And any other variable? No, I don't see any other variable. Okay, so for n going from 1 to n less than or equal to 39, n plus plus. So my n is this number, 1. It goes from 1 to 2 all the way to 39. for all those numbers, I need sum plus equal to, or sum equal to sum plus n times n plus 1 times n plus 2. And that'll be it. When the loop ends, see out sum. Let me show you why it works. When n is 1, when n starts at 1, when n is 1, 1 times, 2 times, 3 is added to sum and stored it back in sum. Then n increases to 2. Now, 2 times, 3 times, 4 is added to sum and put it back in sum. And then n becomes 3. 3 times, 4 times, 5 is added to sum. So when n becomes 39, 39 times 40 times 41 is added to sum. Okay, so that will finish that.
I have a question, sir. If I will do same exercise, but I will not use not for, I will use while, is it will be a mistake or not?
Yeah, while, of course. Instead of for loop, you can use while loop, yes.
Okay, thank you.
Yeah, when it comes to the test, it doesn't matter what loop you use, okay? You can use for loop, while loop. I know that when there was section 4.2, only in the section 4.2, you were supposed to use only for loop to do the problems. After that, you're free to use any loop. Okay, so in the test, you're not limited to for loop or while loop. I will never say use for loop, anything like that. So you're free to use any loop.
Professor, can you do letter A in that homework?
In the homework, number 2A?
No, 4A.
4A, okay. 4A is 1 plus 1 over 3 squared. It's on the screen, on my screen. So you should be able to see that too. If it is too small, I can enlarge it. And so we're doing this problem, part A, adding up this series. 1 over 3 squared, 6 squared, 9 squared, all the way to 729. Okay, so if you look at the denominator, the first term has 1 over 1. 1 squared, you can say, but we don't have to start there. We can start the sum at 1. Then the first term I need to add is 1 over 3 squared. So the 3 is what I need to store somewhere. I will store the 3 in a variable n, and the 3 will change to 6, and then 9 going up by 3, clearly, right? 3 goes up by 3 to go to the 6, and then 9. You have to look at all 3 numbers to see the pattern. They're all going up by 3. So my program can begin with the sum being float type, sum equal to 1. And then I need an int type variable. I will make that float because I'm going to put it under 1 to make it a fraction. So therefore float n equal to 3. N is float now. Since there is pattern in the denominator, I can use for loop or while loop. I'll use while loop for this one. While n is less than or equal to 729, sum equal to sum plus or sum plus equal to 1 over n times n squared. After that, n has to increment by 3. So n equal to n plus 3 as the next statement. And both of these have to be in the loop. So we need brackets. And that'll do it. It's adding up 1 over 3 squared, 1 over 6 squared, 1 over 9 squared, all those, all the way to 729. When the loop finishes, see out the sum. All right, anything else?
Professor.
Yeah.
For for part for part B, I use three variables of n and then multiply. Is that wrong?
Three variables for the three numbers like A, B, C, and then increment A, B, and C.
Yeah.
Yeah, nothing wrong with that. Yeah, there are several different ways to write the program. The way I wrote is probably the simplest, but there are other ways, yes, and other ways are correct too. So your way is correct. If you use three variables and increment each one, nothing wrong with that. Any other question?
Yes. For question 7 on the review,
okay.
I was just curious, do you have to account for fractions less than 1 but above 0? Because if you're squaring them, it just gets smaller instead of bigger.
What power of the number, what power that number should be raised to get the value just over 300? Yeah, according to the problem, the number can be fractional, yes.
Okay.
So you have to account for all of them. So just declare the variable as float to hold the number. Then
got it.
Yeah.
Okay. Because to get to 300, you need to have negative powers. So a half times a half becomes a quarter.
It could, I mean, if it is less than 1, you're right. So it will never hit over 300. But fractional numbers greater than 1 can do.
Yes, absolutely.
Yeah. So therefore, just allow any number and assume that the user knows whether it will hit 300 or not.
Got it. Okay, thank you.
Could you go over the previous project?
Previous project means 3.4.1?
Yes.
Okay. All right, project is right there. Oops, sorry. Right there. Okay. Let's clear the screen. Remember, there are different ways to write program, many different ways. So the program written by each one is normally different. Not only the variable names, but also the structure, how the whole thing is structured will be different. So here, in this project, you're supposed to calculate the bill following some rules that they have. So I'm going to begin with the main and introduce our variable. The bill is basically we are computing, and customer ID is an integer. So begin with the integer variables, int ID, and then last reading, new reading, they're all integers. So last, new, super saver or not. I'll call that saver. So variable saver is going to hold 1 or 0, depending on whether it's a super saver or not. Last will be last reading, new will be new reading, ID is the customer ID. And then I need float type variable for bill. I don't see the need for any other variable. So I'll ask the user to enter the information now. Enter ID, last reading, new reading, save a plan, 100 for saver plan. I'm kind of writing briefly, but a brief statement, but you should really elaborate, asking those very clearly. So I'm asking user to enter all those and CN ID, last, new, saver. For the saver, he will be entering 100. Okay, so I have the information. I can proceed to calculate my bill. All the customers have $8 service charge, so the bill can begin at 8. Or I can add the bill $8 within my calculation. The charges will be calculated based on the used water. So I need a variable for the used water. So used is my variable for that integer. So I'm going to calculate my variable, the value for the variable in, used water. Used water is simply the new reading minus last reading. After that, I'm ready to calculate my bill. So if used water is less than 200, then bill equal to 8 plus the used water. My pen failed there. That's a plus. Used water times, you'll be charged 8 cents, so 0.08. I'll worry about the other details later. Right now, just calculate the bill based on the used water. Else, if it is not under 200, this will be executed only if it is not under 200, which means it's over 200. And so all I need to do is compare it against 800. Used is less than 800. Then bill will be 8 plus used water times 0.07. If that's not true, then it must be under 800. So it must be over 800. So bill will be, in that case, 8 plus used times 0.05. Okay, so that gives you the bill. Now we have to take care of the super saving plan. So you have to make adjustments if the customer is a super saver. So if saver equal to 1, that's when he's a super saver. Only then I need to add the $6 fee. So there are a couple of things to do in this case. One is bill equal to bill plus 6. The $6 fee will be added. And the other thing is, if the bill exceeds at this point, after adding all these, exceeds $35, then 20% discount will apply. So I need another if inside this if. Now we are still working with the saver equal to 1. So saver equal to 1 is true and $6 have been added. After that, if the bill amount calculated so far is over 35, yes, over 35, then I need to decrease by 20%. So that's same as calculating 80% of the original bill. So bill would be replaced with bill times 80%. So this second if is inside the other if. because only for savers, super saver plan customers, this will apply, the 35, the discount 20%. Now close that bracket. I needed bracket because I have two statements. One is bill equal to bill plus 6, and the other one is if statement. Both are inside the if. So that takes care of the super saver, and the bill is pretty much ready, but we need to do the rounding. So only now, when everything is finished, you do the rounding. So
Do you need to put an else after that?
no, because if the saver is not 1, then none of this will apply. The bill will remain same as before. I have seen students writing else bill equal to bill. That shows you that you don't really understand this. This bill equal to bill is what does it do? It's a dummy statement, right? It's a total waste of time of the system. It's why do you want to copy bill into bill? When I explained this at the beginning of the course, and I said, this is a statement you never should write, and I know some of you will write. I said that, and that's exactly what's happening. Some of you are writing. Only if the saver is 1, then the bill will be adjusted. If the saver is not 1, bill will remain the same. So there's nothing to do. You don't need to write bill equal to bill. Okay, so this if statement doesn't need an else. So bill is now ready. All I need to do next is do rounding. So to do that, bill equal to bill times 100. We are rounding at the second decimal digit. Yes, 100. And then add 0.5. And then the whole quantity, I need to take integer part of the whole quantity and then divide by 100.0. If you don't divide by 100 point, you will get integer part of the answer, which is wrong. So now see out. You have to see out all those information basically to create this display of the bill. You're supposed to write ID and all in that form. So you know how to do that. So I'm just going to write the amount due. Amount due. \T. You can do a double tab to make sure the numbers are going to line up. And then you say bill. I'm only writing the last line of the bill. The other ones are just what you have calculated. I did forget to add the tax. Let me go back and add the tax. So somewhere here, before the rounding part, you need to calculate the tax equal to bill times what percent? 6%, 0.06, and then bill minus equal to tax, bill equal to bill minus tax. That line should go before this rounding statement. And so those other lines of the output you had to write because the problem asks you to do that. But I'm writing just the due, amount due, and that'll be it.
It's fine if we where it says enter ID last new, if we do that all on different lines, is it fine?
The ID and last reading and all that? Yes,
Yeah,
you can ask for them one at a time, yes. Yes, of course, there are a million different ways to write this program. This is just my version. So what you wrote could be different, but it could be still right. There's nothing wrong in writing a program in a different way. Okay, any other question?
Yes, can we do homework number 8, question 10, please?
Okay, homework number 8. All right, I have to find that. Okay, which number again?
10.
10. Doing number 10, write a program that obtains 4 float type numbers from the user and prints the largest of them on the screen. Okay, we are only finding the largest. So, I mean, now you can, you have the loop, you can have a loop going 4 times, but I will write it without loop. That's what you're supposed to do at that point. So let's write main, and then we are getting 4 numbers from the user and also finding the largest number. So I'll declare them as float type A, B, C, D, max for the largest. And ask the user to enter the 4 numbers, enter 4 numbers, C in A, B, C, D. Now the technique for finding maximum is to store one of them, any one of those 4 numbers in the max first. If you start comparing them, there'll be too many comparisons. If you compare each other, and it'll be a very long program, and that's not acceptable method. Program has to be the simplest one, has to do the work with minimum effort on the computer part. And this technique uses minimum effort, minimum work. Set the max to be equal to the first number, and then compare each number to the max. So right now, max is holding, let's work with some numbers. Let's say A has a 5, B has a 10, and C has a 8, and D has a 4, just for the sake of understanding. And our max is right now has a copy of the first number, 5. And then I'm going to compare if B is greater than max. I'm only comparing the second number to max, which is true in this case with the numbers we have. So if it is bigger, then copy that into max, max equal to B. So B is bigger, B is 10 bigger. So therefore, B will go into max, erasing the 5. So now I have 10 now. And then I need to do if C is greater than max. I need to compare each number to the max. Now this part can be done as a loop if you are doing more than 4 numbers. We will be actually doing it with more than 4 numbers after we learn about arrays. So let's copy C into max and only compare each one to the max. And is C bigger than max? No. So it will not be copied. So this will not be done. I still have to check the other one. If D greater than max, then max equal to D. Now I have done all 4 numbers. Original number was A, copied into max. Then B was compared, C was compared, D was compared to max. C is not bigger than max, so nothing will be done. D is not bigger than max, nothing will be done. And you can see max has the largest number, right? So when this process ends, max will have the largest number. See out max. This process is useful no matter how many numbers you have. And even if you have millions of numbers, same idea works. Take the first one as the maximum and compare that to each other number. And so if you have many more than 4 numbers, then normally you use loop to do this comparison. We'll be doing that later. All right, anything else? You can ask any question from review or homework, any homework.
There's a similar question to this where it asks you to order the numbers that are given instead of just give the maximum.
Yes.
And I did it with just a big thing of if and if else. Is there a way to do it like this, or is that the best way to do it?
All of them in order, then this method doesn't work. This is only good for finding maximum or minimum.
Got it. Thank you.
Yeah. For the minimum, the same method works. Only the inequalities will go opposite way. Yeah, go ahead.
15, number 15 from the review.
15 from the review. Okay, on that 15, write a program that obtains 3 integers from the user and prints the smallest integer between 2 and 20 that divides all of them evenly. Okay, so we are trying to find the smallest divisor in the range 2 to 20 for all 3 of them. All right, clear the board. Okay, declare the 3 variables as A, B, C. They are integers. And then my divisor, I need test numbers for devices, and I'll call it test equal to 2. I need to test all the numbers from 2 to 20, so I'll use a loop. While test is less than or equal to 20. I have to assume that the 20 included, so less than or equal to 20. All I need to do is make sure that test number is going to divide all 3 of them. If it doesn't divide all 3 of them, then it's not what I need. I need the number that divides all 3 of them. So therefore, I need to make sure the following are true. If A modulus test equal to 0 and B modulus test equal to 0 and C modulus test equal to 0. All 3 have to be true. Then that number is what I need, and I can terminate my process. See, once I find that smallest one, it says I need to find the smallest one. So I don't want to continue the loop when I found it. So this loop goes all the way to 20, and I need to stop it if I find the number. So I need to bring in another variable, which is going to be a flag. So flag variable is going to be added to the int found. So found equal to 0 initially, and as long as found is 0, the loop will continue. So found is 0 means we haven't found the divisor. So initially the flag variable is 0 to mean we haven't found the divisor. So the loop says as long as test less than 20 and found is 0, which means we haven't found the divisor, keep testing the test numbers. And when I see if this is true, then I have found the test number. In that case, I see out the test number. So I need brackets because I need more than one statement in this if statement. See out the test number, that is our answer. And then also I need to set the found to 1, found equal to 1, because I found the divisor. All right, and that's all you need. So here's how it works. Initially, test number is 2, found is 0, and then test is less than 20 is true, found is 0 is true, so therefore it'll test the test number. If that test number is dividing all 3 of them, then it will write the test number and it'll change the found to 1, so that when you go, the test number has to be increased. So test number has to be increased outside the if. So it'll go to this line where test number increases. Now I need brackets for the while loop. So it will increase the test number and go on to doing this only if the found has not changed to 1. If the found remains 0, then the loop will continue. It'll continue with the new test number. So let me go back again. Test number is 2, it's less than 20, and I'm testing to see if that number is dividing all 3 of them. If it divides all 3 of them, I print and change found to 1. Otherwise, let's assume that it's not a divisor of all 3. Then the test number goes up and the loop continues. Test less than 20 is true, so I'm testing the next one. And so I keep testing. At some point, the test number, if the test number found to be dividing all 3 of them, then I'll be printing that, and I'll be changing the found to 1, and still the test number will go up. But then when you go up here, because of this condition, the loop terminates because found is now 1, so loop terminates. So whenever I find the test, I print it, and the loop will terminate. So as I need to do one more thing. If the loop keeps going all the way to 20, that means it never found a divisor. So if there is no divisor that divides all 3 of them in that range, then test will become more than 21, or found becomes no, if found becomes 1, then it was found. So if it was never found, then the loop will terminate by test going over 20. Test will be 21. So you can, down here, you can say if test is 21, then write no device is found. Or you can say if found is still 0 when the loop ends, then that means it was never found. So you can do it either way. If found equal to 0, or if test is 21, then no divisor was found. So see out, no divisor found. Remember, there must be a conclusion regardless of what happens. So there may be no divisor that divides all 3 of them. So in that case, there must be a conclusion. That's what I'm doing here. If the divisor was found, the divisor will be written right there, and loop will terminate. If there was no divisor found, then it will write no devices found. That's how you finish a program. No matter what happens, there must be some answer showing on the screen for the user. All right, so that's all there is on that. Any other question?
Real quick, can we do 1E on the review if we did not go over that one?
1E on the review. Okay, I have to be quick because my next class has to start. So let me see quickly. 1E, A is 10, B is 0, C is 5, if A not equal to 0, which is true. So it'll go to B, the second if, B not equal to 0 is false. So it'll go to the else of that second if, which is this else right here. Right.
No. I said 1E.
Oh, this is not, oh, that's 2E. 1E is this. These are in, this condition will be checked. X plus z less than or equal to y. X plus z phi minus 2 less than or equal to y is true. X greater than z is true. So the combination is true. And the other one is an OR. So even if the right side is a false, the whole thing is true, right? So then the not will, oh wait. No, I'm sorry, I'm wrong. The not will operate after this parentheses operates. So x plus z less than or equal to y is true. Not that is false. The not is going to operate on that. Okay. I thought there's a parentheses for the whole thing. No, we don't have a parentheses for the whole thing. So not will operate on that. So that's false now. And x greater than z is true. The combination is false. This combination is false. And the right side, y greater than 0 is true. So therefore the whole thing is true now. Okay.
Thank you.
The whole thing is true. All right, so I'm out of time. Good luck.
Question, sir.
The test will begin at 7:30, and so that you can have extra time. So start at 7:30 if you like to have extra time.
How many questions?
How many questions? About 40. I believe approximately 40. Yeah.
Thank you. Have a good day. Bye.
Yeah, bye now. Remember, test will start at 7:30, and so if you like extra time, then you should start at 7:30. All right. Good luck in the exam. Have a nice day, everybody.